Well, good morning. I'm Carlos, and today I'll be talking about how to bypass Internet Explorer's cross-site scripting filter. First, a little bit about me. I do not have a computer science networking background. I'm actually formerly mechanical drafting. One of my friends was looking for work, wasn't finding a whole lot in the field, said, "Hey, White Hat Security's hiring. Try this." And so, hello, testing, can you hear me now? Should I start over or? Cool. All right, so yeah, one of my friends said, "Hey, White Hat Security's hiring, try this." And so a little under 3 years later, here I am speaking at B-Sides. So today we're talking about the agenda is basically how I found this bypass, explanation of what exactly is going on in the bypass, so there's a reminder as to not trust browser-based security stuff, and a process for everyone who's in the offensive side of security to actually add this processes to your toolkit. So first, the bypass. Almost a year ago, I was poking around at a website doing a vulnerability assessment. I was visiting the browser in visiting the application in various browsers to see if there's any sort of browser-specific functionality that would appear. I already gone through Firefox, Chrome, Opera, Safari, and last on my list was everybody's favorite, Internet Explorer. Previously, I had found a somewhat interesting cross-site scripting vulnerability. I could get my injection onto the page. However, before that injection would execute, there was a block of JavaScript further up on the page that would check to see, is this page that has the reflection within the iframe of another page? And if the vulnerable page was not within that larger iframe page, it would automatically redirect the user to that outer page with the injection stripped out. I did note, however, in the URL for that bigger iframe page, there was a parameter that allowed me to specify the page within the iframe. So my injection could go from the URL to the source of the iframe definition to that vulnerable page. So it was a step-down vulnerability. So again, I initially found this in Firefox. I was looking around and seeing, is there any browser-specific functionality. I was poking around Internet Explorer, didn't find anything browser-specific for Internet Explorer, and just for fun, I decided to go back and poke at this to see, it looks interesting, might be fun to look at. So, as part of the standard training at White Hat we get for cross-site scripting is we learned that in attribute space, hexadecimal encoded entities are automatically decoded by the browser. So for the two of you who do not know what that is, inside the definition of a HTML element, you have the bracket, angle brackets, the HTML element name, and then all the various aspects of that. And when we talk about landing in attribute space, we're usually talking about an injection landing somewhere in the value part of the parameter equals value pair. So just for fun, and to see how clever I could be with an injection that did not look like script alert script, I encoded some characters that would land as hexadecimal encoded inside the iframe, and I sent that through. And I got an alert box, which is not supposed to happen. My first thought was I was doing something wrong. Maybe I had some settings somewhere turned on, turned off. I was going through all the various settings in Internet Explorer. Okay, everything's at the defaults. This is at the default. This is at the defaults. Okay, maybe there's something wrong with my virtual machine. Just restart it, see if there's something I was doing stupid. No, restart the computer to see if there's some weird thing going on. No. Showed it to the coworker for, okay, am I just being completely and utterly stupid about this? No, it's actually happening. So after that, I sent a report to my management, and I went home for the weekend because it was a Friday and Fridays. So over the weekend, I spent some time building some deliberately vulnerable code that would demonstrate what exactly is going on. Reported it to Microsoft, got a case number, and a bit over a month later, Microsoft came back and said, no fix. So what is going on in the bypass? The cross-site scripting filter has a trust model, and we can abuse that trust model to bypass it. The filter decides which requests are going to be subject to checking and which requests are just going to be let through. So, what's going on? A primary request is made to the page such that it does not cause an immediate JavaScript code execution. With that injected data, a secondary request is made to some page on the same domain that does cause a JavaScript code execution. That first request is subject to the filter. The secondary request passes through without being filtered at all. So, what to look for? So for everybody in the offensive side of security, what you're looking for is ways to induce a secondary request within the same domain. So you're looking for inline frames, form submissions, landing and href attributes, JavaScript redirects, and anywhere on the page where you can get a link in. And in terms of disguising your very first injection, there's various standard encodings that you can use. Hexadecimal encoding, where it's ampersand hash X followed by an alphanumeric character reference, semicolon. The decimal, which is ampersand hash, a numeric character reference, semicolon, named entities, ampersand, some sort of alphabetic string that describes a character, and plain old URL/URI encodings. When going about testing this sort of thing, the filter really does not like periods almost at all. You will occasionally be able to get a period in on your primary injection, but more often than not, the filter will see that, hey, this thing has a period in it. I'm just going to block it, change it, and your primary request will not get through. It also does not like adding your own HTML elements of a form, frames, and iframes. So possibly doing trying to induce a secondary post request may not be all that easy. Sometimes the filter will let through all your parentheses, square brackets, curly brackets, and occasionally the word style. And that style is actually somewhat an important thing to use for the demos I should be getting to right now. So, let's see. Hello, so this is Internet Explorer on Windows 8.1, Internet Explorer 11, the latest and greatest. And our security settings are all at default level. So the cross-site scripting filter is currently on. So I'll just jump forward a little bit. Come on, wireless. So this is what I believe shows the best exactly what's going on. So we have this form with a parameter that lands and becomes part of the page. There's our test injection, and that request is then sent on to another page within the same domain. So again, we can get our tags in, and they are rendered in the vulnerable page. Yes, same domain. So we then make a primary request that lands on the page, but it's when the cross-site scripting filter sees this, it sees that this will not cause an automatic JavaScript code execution. It will not change anything on the page. Your primary injection gets on through. However, the browser itself will automatically decode it. And so a secondary request is made, and the alert box pops. So you the source of the secondary page. Our generic script, source equals external JavaScript file, close script, appears. You can actually look at the requests themselves. So this is the primary request with the injection, and it lands on the page. And it does not cause an automatic JavaScript code execution. Our secondary request is script source equals external JavaScript file, close script. Because the filter checked the first request, it will not check the secondary request, and this gets on through and lands on our page, script source equals external JavaScript file, close script. And again, talking about various encodings, in addition to hexadecimal, we can also use decimal encoding, or instead of the ampersand hash x, it's simply ampersand hash numeric character reference. And inside attribute space, those are automatically decoded. The secondary request is made to the same domain, and we get our alert box to pop. So, again, looking at the requests, our primary request is made, lands on the page, such that it does not cause an immediate JavaScript code execution. The secondary request is made to a page on the same domain, and that secondary request is not filtered at all. So, and this up here, this is actually a mock-up of where I first found this. So we have a page, and there's a definition for the iframe of the page, and a parameter in the URL that defines what page is being sourced into this iframe. So we can then use, for example, a named entity injection. Oops. Just typed the, that's why. Copied the wrong thing. Okay, this time with the correct copied and paste. So we define the page. The page has a vulnerability in it. The iframe automatically makes that secondary request for you without any user interaction. So again, the primary request lands. with characters encoded such that this does not cause an immediate JavaScript code execution. Because we're landing in iframe, the secondary request to the same domain happens automatically without user interaction. And our injected script then executes. So once more, looking at the requests, our primary injection lands with characters encoded. And the secondary request to the same domain, script equals external JavaScript, source equals external JavaScript file, close script. The secondary request is not checked at all. Then, just before the demos, I mentioned the use of the word style. So, in this demo, what I have is a vulnerable page where that's all you get. You can get angle brackets in onto the page. So, our injection lands on the page. We can render our tags on the page. So, what we can do is, because we can inject tags onto the page, is inject a division element with a bunch of CSS that completely covers the page. And now you have, for the user, hey, the page you really want is right here. You should click this link to go get it. However, when we look at the source of the page, here's our division element, style, with our CSS elements here defining the division element to completely cover the page so that the user, that's what they see. And then a link back to the very same page with our injection. And since we're landing in attribute space, all these characters will be automatically decoded for the secondary request. So the user says, hey, I really want to be over here, clicks the link, and our script is injected onto the page. Script, source equals external JavaScript file, close script. Once again, looking at the requests, our primary injection lands on the page, completely covers the page so that the user sees that all they want to do is click that link. Secondary request is made. Script equals external JavaScript file, close script. That secondary request is not filtered. And an injection lands on the page and is executed. Okay, I believe I have time for one more demo. So, for examples of a page where we actually have, there's a JavaScript redirection to another page on the same domain. So, in this secondary page, there's a parameter that lands on the page, and as before, we can get our tags in. So we can use in this case is that when we look at the source, oops, not fast enough. So our injection lands on the page. There's a JavaScript that will redirect it to the landing page with a cross-site scripting, and our injection is simply URL encoded with some characters such that it will not cause the immediate JavaScript code execution. However, when it gets redirected to the secondary page, it does execute. Everything's decoded. in our script, source equals external JavaScript file, close script, is executed. And again, looking at the requests, our first page lands. Our injection lands as simply URL encoded in JavaScript space. The redirection happens without user interaction to the secondary page, where injection script source equals external JavaScript file, close script, lands and is executed by the browser. Oops. So, when I first got word that Microsoft was not going to fix this, I was actually given two separate reasons why this would not be fixed. Once in the immediate aftermath of my report, and then a second reason several months later when this became public. Initially, it was because it requires special functionality. That's not actually true. Everything that we've used here is part of the HTML standard, and it has been since at least 1998, if not sooner. The second was that this is the later reason was because it requires user interaction. That's partially true in the case where you inject links, or maybe there's some form that needs to be submitted. But in the case of JavaScript redirects or iframes, those are actions that are automatically taken by the browser without user interaction. So the website that I had up there, I have a bunch of cards up here. They'll give you access to that site so you can poke around it yourself. The PHP code that's running on the server is up on my GitHub page, so you can go there, download it, run it on your own server to show that I'm, this is Vegas, but there's nothing up my sleeves. So, are there any questions?
So, if you coded your web page correctly, and you, before, I believe there was always a cross-site scripting filter, and previously you have to, specifically code your page to protect against this stuff. If you continue to follow those practices, you wouldn't be vulnerable to this.
That is correct. If you code your page to make sure that the generic primary injection JavaScript cross-site scripting is not possible, this is not possible at all.
Okay, well, there's one more thing. I haven't been coding in HTML for a long time. What does this cross-site scripting filter do? And this is other applications do this correctly?
What the cross-site scripting filter does, that's the question. So the cross-site scripting filter checks the requests and responses sent by the browser to see, does this request that is made cause the reflection of code on the page such that it would cause an immediate JavaScript code execution. Again, in Internet Explorer, there's this trust model of which requests are filtered and which requests are not, and we can use that trust model, abuse it, and get our injections past the filter. This does not work in Chrome. It does not work in Firefox with no script. It just works in Internet Explorer. I believe the question is, will this work with content security policy? I have not tested it, but my guess is that this will not work with content security policy. So the question is, when is the injection decoded? The injection is decoded automatically by the browser at the start of the secondary request. After the first request is made, the filter just checks the first request, not the second request. Yeah. Oh. Thank you.